We're going to finish up with day 3 today of 6.5. So this is solving equations using completing the square. It's kind of the same thing we've been doing, except for there's not going to be a y in the equation. We're actually going to solve these equations for x by the same kind of methods that we've been doing by doing completing the square. So there's really not much different besides we're going to go a little further and actually solve these equations fully. As you can see, there's no y's in these equations. Right? There's no y here at all. We're just going to solve this for x. Now, normally, what you would probably do is you try to figure out, like, well, how do you get x by itself? But the biggest problem here is that you can't, because x squared and x here are not like terms that never go together. So we're going to just use what we normally can do by following the same steps that we use for completing the square. Same idea. So the first thing we were supposed to do is a very basic one we did a little bit ago. We label ABC, and the first step says to move the c value over, so I'm going to subtract 10. So that allows us to get x squared minus 8x, and then if you remember, this is where we put in a blank spot. And on the other side, you have 3 minus 10, which is negative 7. Oh yeah, also put a blank spot on this side. And then we're going to go off to the side, and we're going to use negative 8, and we're going to divide by 2 and square it. This stuff is nothing new at all. We're going to use negative 4. We're going to square that. We're going to get 16. 16 goes here. 16 goes here. We're going to factor this. And what do we get when we factor that? Oh, yeah, we can add these two together on the right side. So negative 7 plus 16 is 11. Sorry, it's 9. Thought that didn't sound right. 9. There we go. And then in here, we're going to get x minus 4 and another minus 4. Everything we've done so far is very, very similar to completing the square that we learned before. You bring the c over, you go off and do the b over 2 squared, you add that to both sides, and then we're going to factor. Nothing different. So now we're going to squeeze those two things together. We have x minus 4. Whoops. Let's go ahead and erase that. We have x minus 4 squared equals 9. This is kind of the new part here. At this point, we would bring over the 9 and just say we have y equals, but then we don't have that here. We're actually going to get x by itself. So now that we have something in a quantity being squared, we're going to square root both sides of the equation. And at this point, as soon as you square root, we've done this stuff before though, you get two different answers. It's going to separate into two different things. So when you square root this side, it actually takes out the squared and the square root, and you get x minus 4 equals the square root of 9, which is 3. Or you can get x minus 4 equals the square root of 9, also the negative version of that, negative 3. And then you can solve these individually by adding 4 to everything and getting your two answers. So one answer we'd say would be x equals 7, or add negative 3 plus 4, x equals 1. So those are your two answers. So here's one way you can actually solve these equations, whereas you normally would not be able to do that. Also, you would not be able to get one side equal to 0 and factor, because this would not be a factorable problem. Sometimes they are, sometimes they aren't. It just depends. I'm going to try like just one more and then probably do a word problem that's on the back side, and then I'll be finished with this video. I'm going to try to do one that's a little bit harder where we have like a GCF we have to pull out. The first three are done very similarly, and then we have 3 more that are done as well very similarly. Let's try the last one, F. So if I label my A, B, and C, I'm going to bring over the other side this plus 6, and I get 5x squared plus 20x, and then there's nothing here, equals 15. All right, now this is the step where we actually have to take out the 5. If you remember, we're going to factor that out. We get x squared plus 4x plus a blank equals 15. I guess I'll put my blank spot on this side as well. Not a 4, a blank. And then we go off to the side, and we're going to do 4 divided by 2 and square it. So that's 2 squared, or 4, which actually means we added in 5 times 4, which is 20. All right, now we can factor this. We have 5 times x, 4 and 4. That'll just be 2 and 2, right? You have 2x plus 2's, so it's squared. And then 15 plus 20 is 35. All right, at this point, we're actually at the same part up here as we were up here when we did the square root. Pretty much the same place. But before we do square root, we actually have to get rid of this 5 first. So what I'm going to do is, since I have multiplication here, I'm going to divide by 5. That goes away. So I'm going to get x plus 2 squared equals, oh boy, that's not good, 7. The only thing that's bad for is that we're not going to get a nice number here. So at this point, this is where we're going to get rid of the squared by square rooting. And if you square root 7, you would not get a nice number. That's okay. So go ahead and square root 7. We'll just have to estimate as best as we can. It's going to be about 2.64 or 2.65 if we round up. So we'll use that. I'm running out of room here. We're going to have two different answers. We're going to have x plus 2 equals 2.64. Or, I'm going to put the other one over here, x plus 2 equals negative 2.64. Oh, no, let's change it to 5. Let's round that up to 5. Five and 5. And the last thing we have to do is subtract 2. So this one's going to be 0.65. Or if we minus 2 here, we get x equals negative 4.65. So again, you can have decimals in your answers, and even though it looks ugly, that's sometimes just the way it works. So the rest of them you can go ahead and finish. There's, 1, 2, 3, 4 left. And then on the back side, we'll do the word problem. So number 2 on the back, and then we'll be finished. Suppose Mr. Callie is shooting Mr. Miller out of a cannon. Mr. Miller's trajectory is defined by the equation h of t equals negative 16t squared plus 64t plus 10. Alrighty. So let's pretend I'm getting shot out of a cannon. Okay, I gotta maybe draw one. So you have like a cannon, and my body's in there. I'm getting shot out of it, and I'm gonna go up in the air and then come back down. There we go. Picture this as a cannon. Something like that, yeah. And then this is the equation that we're going to use. It says find Mr. Miller's maximum height and at what time he reached that height. Okay. So if we're going to find the maximum height, what we really need to find is the vertex. And we have to find what time I reached the height. So let's go ahead and find the vertex. So we will go ahead and change this into vertex form. We don't know the height. And what time would that be? So I guess we'll just leave this. Maybe we'll change this to y to make it a little easier. All right. And then I'm going to go ahead and go through my normal ways of figuring this out. What we might be able to do here is, I think we'll do the same thing as we did before. I'm going to go ahead and minus 10. It's kind of old school of doing this. So I just changed h of t to y just for now because we're used to using that. Y minus 10 equals negative 16 t squared plus 64t. Then I'm going to factor out this negative 16. Don't like that. So that gives you t squared minus, I think it's 4t, plus a blank on this side. Then go off this side, and we're going to take negative 4. We're going to divide it by 2 and square it. That gives you a positive 4. But we're actually putting in a 64, because negative 16 times 4 is negative 64. So that means we have y minus, add those two together, you get negative 74. Negative 16, we can factor this. This would be t we have minus 2 squared. And then we would add over the 74. Okay, so I'm not going to use the y again. I'm going to go back and use my h of t. So it's h of t would be negative 16 t minus 2 squared plus 74. So how does this get us the answer? Well, let's look here. The vertex, if you look at this equation, would be, change the sign of this, would be 2 comma 74. So what does it actually mean? Remember, we're looking at the time as it goes across the x-axis. This is time. So our x value is actually 2. And then our y value is our height. And so since this is a vertex, this is the very, very top part that I'd be getting at right here. And the time there is our vertex, which would be 2 seconds. And my height would be at 74 feet. So really that's your answer. It answers both things. It says find Mr. Miller's maximum height. The maximum height would be at the vertex. And at what time he reached that height, we found the time. It'd be 2 seconds. So 2 seconds, he would be 74 feet. Well, I should probably put feet over here. In the air. So this problem really was just changing from standard form to vertex form. And then one part to this. How many seconds will it take for Mr. Miller to be 26 feet off the ground? Oh, okay, so now we're looking for a very specific amount. So maybe we would say like here is 24 feet. We're saying, how many seconds will it take? So we know the height to be 24, but we don't know the time, right? Seconds we don't know. But we know the height, this side of the equation, is 24. So I'm going to plug that in. 24 equals negative 16 t squared. What else do we have here? Plus 64t plus 10. So I'm going to go through most of the exact same steps as I did before, but the only difference now is that instead of having y here, we're actually going to solve it once we get down to this point here. So you'll see how that changed. Not much is going to change. I'm going to copy most of the stuff down because it's the same kind of steps. So the first step we did was minus 10. The only difference is we don't have a y on this side. So this would be 14. And then factor this, which we already did, copying that down. I believe we did t squared minus 4t, and we added 4 here, which meant we added 64, or minus 64. There we go. And so that would be 50, negative 50. All right, now we have negative 16. And then this one factored to t minus 2 squared, so same answer as before. And now we're going to go ahead and finish solving this. So I'm going to take the negative 16 and divide it. And so that's going to give us a decimal, unfortunately. 3.125. Which equals, this goes away. We get t minus 2 squared. And then we're going to square root both sides. I'm going to split this into two different things. If we square root 3.125, it's going to be a pretty small number. 0.125. It'll be 1.76 or 1.77. I'll round that up to 1.77 equals t minus 2, because remember this goes away. Or negative 1.77 equals t minus 2. And then to solve this, I'm going to add 2 to both sides. And so that would be 3.77 equals t, or like 0.23, something like that. 0.23. So here's our times, right? So this means that at 0.23 seconds, what does it say here? How many seconds will it take for a solar to be 26 feet off the ground? There would be two different times, and I hope that makes sense. At first, All right, I'm 26 feet here. This would be like my 0.23 seconds. But then I go up in 2 seconds, I'm already at 74 feet. And then coming back down, I don't know if you noticed, but parabolas are very similar on both sides. This would also be 24 feet. And that would be at the other time that we found, the 3.77. And that would be in seconds. So those are the 2 times where I'm actually 26 feet off the ground. Okay, so I just realized that it says 26 and not 24. So you'll have to redo that problem. So I guess it should be very close. I don't know what the answer is specifically, but I can probably work through it again and see. But yeah, I just realized that it was 26 feet and not 24 feet. So I guess I calculated it was 24 feet. So anyway, the time should be very close to those 2 things, although it might be off a little bit. Let me check and see how different that would be. That'd probably be pretty different. Oh yeah. So the difference is I think it would be 3 seconds here instead of 3.125. It should be this. Oops. T minus 2. There we go. This is really what you should have gotten as 3 because this should have been 48. Then you square root 3. Still going to be ugly, but should be a very similar answer as well. So this would be 1.73. So very, very similar answers for sure. And negative 1.73 equals t minus 2. So you can go ahead and finish those 2. Again, that'd be very, very similar to the answers that we got because it was only 2 feet of difference. But that does finish up day 3. It is only 2 pages, and you only have to do those 4 problems that are left.